Alright, what's up everyone? I want to say first of all, sorry I was late to the session today. I was just got caught up getting my lunch, and that's like, I know your guys' time is valuable, and I really don't mean to waste it, and I promise I'll be there on time most of the time. But I just wanted to make a little, since I did miss like a portion of the lesson this morning, I just kind of wanted to make a little video on what we went over and like the important stuff we went over. This isn't going to be all the stuff we covered in our lesson, but this is, I think, one of the main points that a lot of the people were, there to learn. So I just want to talk about dynamically allocating memory in general, and also dynamically allocating memory for arrays that are 2D. And I'm not only going to allocate memory for these arrays, I'm also going to show you how to like free up the memory for these arrays. So first, I'm going to start with very simple, just allocating memory for an array that holds 4 integers. So first things first, we need to declare the array. We need to give it a name. So it's going to be an int type array. And oh yeah, I'm using code blocks because I know a lot of you guys use code blocks, so hopefully this is going to be kind of helpful for you guys. So we're going to have an integer array, and since it's an array, we have to give it that star. Or you can say that it's an array, or it's a pointer to an array. But just know that both of those things, they're the same thing. A pointer is an array, and an array is a pointer. So we have an integer pointer, and we're going to name it array. And you guys usually know, like, the standard method would just, you can give it these brackets, and you can say 4, and then you have an array size 4 right here. But we want to do this dynamically, because there's going to be many situations where you're not going to know the length of the array that you're going to be creating. So you use dynamic memory allocation to be able to do that without, like on the spot kind of, once you figure out what size you're going to need. So let's say we don't know that it's going to be size 4. Obviously we do know it's size 4, but let's say we didn't, and then we just found out. So this is how we would write code to do that. So we'll do int array, and then equals. And I want to talk about malloc. Malloc is super important in C. Malloc is one of the best tools, one of the things you're going to use most often in C. It's kind of what C, the whole memory management thing, revolves around malloc. So what malloc does is it returns a memory address, but it doesn't know what kind of memory address it's going to return. You have to tell malloc of what kind of memory it's going to hold and the size of that memory. So we know we want it to hold integers, okay, and we know we want it to hold 4 integers. So we're going to do 4 because that's how many cells we want, and then we would do times the size of an int. Perfect. So pretty much what this line here does, line 7, is going from right to left, malloc finds a memory address that holds integers, and it's going to find 4 cells to hold 4 different integers. And this is going to make an array size 4 that's all going to have integers. And I actually made a PowerPoint to kind of show what this would look like in memory. So this is what it would look like in memory. We write that line of code, and then it would create something like this. What malloc does, it doesn't know like what is supposed to go into the cells, so it just fills it with random things of that type. So since it's an integer array, it just put random numbers in there, and I just put 2, 7, 8, and 4 kind of to like represent that. There's also another tool called calloc, and what that does is does the same exact thing, except it fills all the cells with 0. And that's like pretty useful depending on what you want to do, but for right now, we're just going to focus on malloc. Cool. So we just made this array size 4. Go back to code blocks, and that's pretty much it. Very basic, very simple. You should learn this stuff in Intro to C, but I understand like a lot of you, it's been a while since you took Intro to C, so I just wanted to review it real quick. Now I want to talk about free. So we just created that array. Let's say we did what we need to do with that array. Now we want to destroy it. There's another tool or keyword called free. It's pretty simple. And what free does, it pretty much, you just give it, once you allocate memory for something, that is forever gonna be in memory unless you tell C that you don't need it anymore. So what free does, it pretty much does that. You say free, and then you pass it the memory address, the memory address you don't need anymore, and it's gonna free up all that space so it can be used for other things. So we're gonna pass in, as you can see here, we're passing in the array that we just created, and so we can just tell C destroy or free the array. And this is what this is going to do pretty much here, and it's going to get rid of that array we just made. So yeah, those are pretty simple things, but you know, they're used in really you're going to be using them in very complex situations. So I really wanted to, you know, go over them so you guys had a good understanding of free and malloc. Now we're going to get into the good stuff. Now we're going to dynamically allocate memory for a 2D array. You know, some people can be, they're kind of scared of this. They think it's a little intimidating, but it's really not that hard. It's just the same thing we did up here, except you're going to do it multiple times. So I like to think about it as pieces. So a two-dimensional array, the first piece is going to be a single array. In that single array, every cell of that array, it's going to hold its own arrays. So let's start with that. So we have an integer, and then we're going to do a double pointer, and that just kind of is telling C that you're having a 2D array. So we have an integer double pointer, and we're going to call that array as well. And we're going to set that equal to malloc. And remember, malloc is going to return a memory address. If we want a double array, our first row of cells is going to be all, they're going to be their own arrays, if that kind of makes sense. I have in the PowerPoint I kind of explained it a little bit better. So we're going to do 4 because we want 4 rows times, and we're going to do size of an integer pointer. Yeah, so the reason we're doing it, remember, every pointer is an array, every array is a pointer. So if we want to make an array that holds arrays inside of it, our first cell is gonna, our top cells is gonna be made of integer pointers, if that makes sense. And if we look at the PowerPoint, let me see, so it look like this. I put the stars to denote that they are pointers themselves. So imagine once we get going, every single one of these cells are going to have their own arrays coming off of them. So let's code that up. So we made an array, you know, it holds 4 of its own arrays inside of it. And now what we're going to want to do is we're going to want to go through that array, and we're going to want to allocate memory for every single cell that holds a pointer. So we're going to have a for loop. We're going to have 4 int I, and you know, there's multiple ways you can go about doing this, but I mean, you can use a while loop, you can do recursion, you know, you can do a bunch of crazy things. But the for loop, pretty simple. I like to stick with that. If I can use a for loop, is what I prefer to do every single time. So we have int I, I'm going to equal 0. We're starting at 0 because remember, the first cell of every array is the 0th index. If we started at any other number, we would be missing cells. So we have int I equals 0. I is less than 4 because we know we have 4 of them. And then we're going to do I plus plus. And that is going to start our for loop. So now what we're trying to do here is we're trying to go through an entire array, and we're trying to allocate memory for every single individual cell. So we're going to use malloc. We would go array, and then we would go array I, because remember, as the for loop goes through, so array I is going to go from array 0 to all the way up to array 3, pretty much. So just like we're starting at the beginning, array 0 equals, remember malloc, because we need a memory address. And now this is where we make our actual integer arrays, if that makes sense. So we're going to do 4, or we can do any size we want. This works for We can do the size 4 again. We can do size 10. We can do the first cell size 4. We can do the second cell size 10. We can do the third cell size 6. You know, it doesn't matter. We can do whatever size we want at this point. We just have to tell C to do it. So let's just stick with 4, you know, to keep it, so you guys can keep it simple. 4 times size of int. So let's just go through what we have first. This first line right here, it's declaring an array of arrays, and then this for loop is gonna go through that array of arrays, and then this line right here is going to create an array of integers in every cell of our array of arrays. I know there's a lot of array words in there, but I hope you guys are following along. So let's see what that looks like. So we'll go back to our PowerPoint. Oh, there we go. We're at our PowerPoint. We have our array of arrays. We do that for loop, and here we go. I put these arrows here to kind of show that, you know, like these up here in our cells, these are pointers themselves. So whenever I'm dealing with pointers, I like to draw arrows just because it's easier for my brain to understand. You know, like a pointer is pointing at something. So as we can see here, so this is actually an array of arrays, and they're size 2. So let me go back to the code and fix that because I did size 4. So these would be size 2, you know. Perfect. And then we'd have this guy right here. And that right there, we have a 2D array, you know. And remember that each one of these cells can be variable length. They can be their own length. I just did size 2 for all of them because it's easiest to understand. Now, let's go to free this. Now that we've created this 2D array, you know, let's say we've used it, we're done with it, we want to destroy it now. We're going to kind of use the same concept, but I would like to go over something that's a very common error. Excuse me. A very common error is a lot of people, they would love just to be able to be like free array, and that's it. They're like, awesome, our 2D array is free, you know, case close, like we deserve arrays. But it doesn't actually work like that, because remember, our first array has its own. Each cell have their own arrays inside of them. So if we go back to our PowerPoint here, let's say we did that statement, and we freed that top row of arrays. You see how we still have these red boxes here? These red boxes would be forever lost in memory, and there would be no way to access them, because the only way to access them was through these original pointers here. So if we free that array, we're going to free those top pointers, but C is not smart enough to know that we also wanted to free the things inside of those pointers. So how would we fix that? It would be the same way that we created the 2D array. We're going to use a for loop, and we're going to go to every single cell, and we're going to free every single cell individually. So, for int I equals 0. I is less than 4 I plus plus. We're going to open our brackets here, and now remember we already allocated the memory, we just need to free it. So we're going to use the same denotation, array I, or sorry, we're going to want to free array I. And so this is going to go through our for loop, and it's going to free every single column individually. So let's see what that would look like. So what that would look like is, it's going to bring us back to this right here. So before we're here, we go through the for loop, we free every single column individually, and then we end up with something like this. Cool. See, we're almost there. Now that we've cleaned up, you know, that memory that was like really deeply seated in there, now we can free our whole array. So after that, you know, we freed our arrays of pointers, you know, our integers array. We freed all of our integer arrays inside of the for loop, and now we can free the array of pointers itself, like this. And so after running this line of code, we would get here, We got no memory. As you can see, just if the screen was the memory in your computer, we freed up everything. We have nothing to worry about. We're a-okay. We're first place. Like, we rock. Awesome. I'll just go over real quick. I know that was kind of a crash course. Like, this was just part of what we went over in our lesson today. We also talked about linked lists. That's a whole video on its own. But I feel like this, for what you guys are going to be working on at the beginning of the year, is the most important thing to really understand, is with like this allocating memory and stuff like that. So we'll start from the beginning. First, we allocated memory for a single array with malloc. Remember, malloc returns a memory address. You just have to tell it what kind of memory you want it to hold off with the size of operator, and then how many blocks of that memory you want. So we wanted 4 ints, and that's going to give us an array of 4. And remember, to free, just like a regular array, you just use the free command. And to allocate memory for a 2D array, we would first allocate memory for the first row, and those would all be their own arrays. And then we would go through every cell in that row and allocate memory to those rows themselves, and those would have their own arrays in them. And the best way to do that is with a for loop. And to destroy a 2D array, remember, we have to go from the inside out. So first we have to free the memory that's the deepest in the array, if that makes sense. That's seated the deepest. So first we're going to go into the array and free the individual, or we're going to go into the pointer array and free the individual arrays. And then when we're done with that, we can free the actual pointer array itself, because we know that we're not going to lose any memory there. Awesome, guys. I'd like to say, thank you so much for everyone that came out today, and I'm really sorry I was late today. I promise I'll be on time, and I really appreciate you guys coming out and really making these lessons fun, and I hope to see you guys in the near future. Thank you, guys.